what you see here is it's like you're getting almost getting an oxyhydrogen explosion inside the impact chamber. You can see the steam blowing out. Now we're using fresh water. If we had used seawater, it would be a very significantly more violent explosion. But yeah, sure. Yeah, this is similar to the earlier video where you had the really violent explosions when we ran seawater. This is running using purified fresh water. Yeah, I mean it's the pressure relief valve is set at 1,000 psi. So this is it's what's happening inside the impact chamber is greatly exceeds 1,000 psi to make this happen. So it's very interesting. A lot of energy being released here with each of these injections. Yeah, well, originally when we did this with seawater, we got 6 of these injections and the thing blew up, the pressure relief valve. But, you know, this is quite a lot of energy being released. Yeah, I mean, you're getting these explosions every injection, so almost certainly it's producing oxyhydrogen inside the impact chamber. With the crushing of the cavitation bubbles, the gas becomes a plasma, and the oxygen and hydrogen are just stripped of electrons, and you get enough molecular oxygen and hydrogen in there and it blows up. I think that's probably enough. 2 minutes. All right. What's very interesting is you can see here from the thermocouple display that the temperature is actually increasing with each of these. But you'd think the opposite. If you're releasing the steam and releasing the heat, the temperature would be dropping, but it's actually increasing. It's true the heater's on, but the amount of heat that's going into this is relatively small. So, yeah, it's... But the reason for that is these explosions that are occurring inside the impact chamber are causing the temperature, the bulk of the impact chamber containment vessel to increase. Yeah, that's true. You can imagine if you had 8 of these in tandem, you would be producing some serious steam. And we're not losing heat. It's actually heating up. It's pretty remarkable. If you look at one of the earlier videos where the steam is pouring out and there's one single large explosion, that was also with the seawater. But no, the steam is coming out continuously, but you clearly are getting an explosion inside the impact chamber to get the with every injection. Yeah, it's remarkable. But apparently it's critical. The pressure was one of an important factor, because if you look at some of the earlier videos, we're not getting these explosions with the fresh water. But when we run the pressure up over 1,000 psi, we get 900 in this case. We get an explosion, which is quite remarkable. It further reinforces the fact that the only way that can happen is that you get dissociation of the oxygen and hydrogen in the water because of these enormously high temperatures that occur during the crushing of these cavitation bubbles. Which is predicted by the Rayleigh-Poiseuille equation. Now I got 6 minutes of this, and as you can see, yeah, the temperature is continuing to go up. Yeah. That all right? Now you can see the heater is turned. You can see the little red indicator light here is off, and the temperature is still going up, even though we're not putting any external heat in. All right, so yeah, I think we're increasing the pulse rate. This thing is really, oh my God. Now I see the steam is really coming out of here. Yeah.